A solution is a homogeneous mixture. It can be a solid, a liquid, or a gas mixture. Most time when we're talking about solutions, we're talking about liquids though. A solid solution would be like an alloy, and then we also have gas solutions comprised of multiple gases. Solution composition has a variable composition, meaning there's no formula to it. It can be defined as concentrated or dilute, but those are qualitative terms. They mean different things to different people. Some people may think 3 molar hydrochloric acid is very concentrated, while others may think it has to be 12 molar to be concentrated. Quantitatively, we're going to use molarity, mass percent, mole fraction, and molality, because those mean the same thing to everyone. Your 4 equations for those are located here. You will need to know those equations as well as dilution. Molarity is represented with a capital M. It's moles of solute. It's very important that you know moles of solute over liters of solution. Mass percent, or the weight percent, is going to be the same thing as all percents. What mass of what we're looking for over total mass times 100. Mole fraction is no units on it, and we have that chi A. This is going to be just like what we did in the gas law unit. It's moles of what you're looking for over total moles in solution. Molality is a lowercase m, and it's also moles of solute, but we want kilograms of solvent. So notice the difference between molarity and molality. Molarity, liters of solution; molality, kilograms of solvent. In very dilute solutions, molarity and molality are going to be very similar, if not the same. The more concentrated, the bigger difference. And you also need to know your dilution equation, which is M1 V1 equals M2 V2. And remember that M was your molarity and V is volume. You should know that molarity can change with temperature, because when you change the temperature, the volume of the solution is going to vary slightly. So here is a problem where we need to calculate our molarity, mass percent, mole fraction, and molality. So I'm going to calculate the molarity first. They gave me grams of each of the substances. Ethanol is going to be my solute because it's in a lesser quantity and they're both liquids. So first thing you should probably do is write out your equation. Molarity of moles of solute over liters of solution. So although they gave me grams of ethanol, I'm going to have to convert it to moles of ethanol. If you've forgotten what the formula for ethanol is, draw it out. So eth is 2 carbons. If it ends in OL, then it's an alcohol. And so we have C2H5OH. Now I can calculate my molar mass and convert that to moles. So go ahead and calculate your molar mass. You should have gotten 46, which means you have 0.022 moles of ethanol. I'm going to go ahead and convert my grams of water to moles as well, since I'm going to need that in a few minutes. And I have 5.55 moles of water. So for my molarity, I need moles of solute, which was 0.022, over my liters of solution. If I look back at the top of the problem, it says that the final volume is 101 milliliters. So that's my liters of solution. I just need to convert it to liters. So dividing by 1,000, I get 0.101 liters. And then dividing my moles by liters, I get a molarity of 0.22. To calculate mass percent, I'm going to put mass of what I'm looking for. If it doesn't specify, then you're going to use the solute. So I have 1 gram of solute, and it's over total mass, which is solute plus solvent. So I have 100 plus 1, giving me 101 final mass. Okay, a common problem is people putting 100 on the bottom because they don't add the solute and solvent together. So be careful on that. So our mass percent is 0.99% ethanol by mass. Our mole fraction, we've already calculated our 2 moles, so that's easy now. And when you do your mole fraction, list what substance you have next to the symbol. So again, it's moles of what I'm looking for over total moles. So just like mass percent, I'm going to have to add my moles up. And so I have 0.004 as my mole fraction. Again, there's no units on mole fraction. And finally, I have molality. So molality, remember, was moles of solute over kilograms of solvent. So I still have my same moles, 0.022. But now I want kilograms of solvent. My solvent was water, so I need to convert my 100 grams to kilograms, and that's 0.1. Dividing, I get 0.22 molal solution. Whenever you see molal, that's just molality. I also could have used a lowercase m, while a molar solution is a molarity. So again, you can put lowercase m or a molal solution. Go ahead and pause the video and try this one on your own. So in this problem, you're looking for molarity. Or you're not looking for molarity, you're given molarity. So molarity, moles of solute, liters of solution. They gave me my molarity, and they didn't give me moles or liters, but they gave me grams. So I can convert my grams to moles. Doing so, I get 0.011 moles. And now I can easily solve for liters by multiplying both sides by liters and then dividing by 0.014. And so my liters is 0.786, which is C. Go ahead and pause the video and try this one on your own. If you got B, then that concludes this video. If you did not get B, then keep watching and see how we get B. They gave us a molal solution, so we're using molality equals moles of solute over kilograms of solvent. We plug in our molality, and they didn't give me moles of solute, but I do know how much solvent I have. So I can convert my 1,300 grams of solvent into kilograms. Again, divide by 1,000. So I get 1.3 kilograms solvent. And I'm going to look for my moles. Multiplying those, I get my moles of 0.221. Remember that moles is simply grams over molar mass. I know my moles, and I know my grams of solute, which was 40. So I can calculate my molar mass by dividing our 40 over 0.221, and so I get B.